Little's law is one of the most useful results in queuing theory. It gives a simple relationship between how many customers are in the system, how long they stay, and how quickly customers arrive. Here we are looking at a basic single server queue. Customers arrive from the left, wait in the queue if necessary, get served one at a time, and then depart on the right. There are two natural ways to count customers here. We can count everyone currently in the system, that means people waiting plus anyone being served, and then we can count only the people still waiting in the queue. There are also two important time measurements. The first is the sojourn time, usually written as S. That is the total time a customer spends in the system from arrival to departure. The second is the waiting time, written as W. That is only the time spent waiting before service begins. Little's law states that the average number of customers in the system equals the arrival rate multiplied by the average time each customer spends in the system. For the whole system, the first equation, that means the average number in the system equals lambda times the average time in the system. And for the queue alone, the second equation, the matching statement is the average number waiting in the queue equals lambda times the average waiting time. This is a very natural relationship. If customers arrive at an average rate of lambda customers per unit time, and each customer stays in the system for an average amount of time, then those two quantities together tell us the average number of customers present in the system. The same idea works if we look at only the queue. If customers enter the queue at some average rate, and each one waits for an average amount of time before service begins, then that gives the average number of customers waiting in the line. Note that in this queue-only version, the lambda term should be interpreted carefully. It is the arrival rate relevant to the queue quantity being measured, so it is not necessarily being used in exactly the same sense as in the full system version. The main idea is simple. Average number equals arrival rate times average time. The takeaway from all of this is that if you know how fast customers arrive and how long they spend in some part of the system, then you can work out the average number of customers there.